Hi guys, welcome to the session. Minecraft, hello. Hi Rajtesh. Hello Zudeb and Rock. Welcome to the session, guys. A very good afternoon to all of you. A warm welcome to the session of trigonometry. This is the second session. First session we did on last Monday, I believe. So you can check that out, and this will be the next session which you're going to be talking about. Mustafiz, hello. Hi Prachi. Yeah, cool names, guys. Good afternoon, everyone. So let's get started. Look, today what we're going to be talking about is we'll be primarily discussing about the questions wherein we need to find out number of solutions or we need to find something regarding the solution. So primarily it'll be all about trigonometric equations. It'll be all about trigonometric equations. That's what we're going to be discussing about today. So let's get started with the topic. Also, one quick announcement in the beginning of the class. There is a news today, and that news is that your JEE Mains results will not this time be ranked, but they will be percentiles. So you're going to get percentiles, not just the ranks. So precisely 100 percentile implies that you have scored the highest marks. Okay, so that is one extra information which I wanted to post today. Anyways, let's get started with the questions which I have. So I've collected decent questions which are from advanced as well as mains. We'll get started with the first question, which is of JEE Mains 2018. Right. Zudev, I'll talk about that in our batch. So just remind me over there. Okay, so let's get started. The first question there on board is, if the sum of all the solutions of the equations is k pi, then what is the value of k? So basically what we need to find out is we need to find out the sum of all the solutions, of this equation. So the question is quite simple. You just need to apply a simple formula, which I hope all of us know. Cos A plus B times cos A minus B. We all know about it. It is cos square A minus sine square B. Right, so we'll apply the same formula in order to solve it further. So just a moment. So I'll use that. So I'll say this is nothing but 8 cos x. Then this can be written as cos square pi by 6 minus sine square x negative 1 by 2. That is equal to 1. So you just need to solve this equation. And in today's session, we'll primarily solve the equations only. Okay. We know cos pi by 6, which is cos 30 degree, is root 3. So this turns out root 3 by 2. This turns out to be 3 by 4 squared minus, this can be written as 1 plus cos square x. Sine square x is 1 minus cos square x. I've just replaced the same. Minus 1 by 2. So basically our motto will be to convert everything into cos, so that finding out the answer would be easy for us. Good afternoon, everyone. Welcome to the session. Okay, so let's just quickly do this. So minus 1 by 2 minus 3 by 2 minus 3 by 4. If I take the LCM, so I'll get 4 and then 3 minus 4 minus 2 plus cos square x is equal to 1. I'm doing it step by step, so I hope you can focus and you can understand this. 3 minus 4 minus 2. This is what we're going to get. Eventually, you're going to solve it. So negative 3 by 4. So if I write it properly, it'll be cos square x negative 3 by 4 is equal to 1. Right, I've not taken that 4 over there. So let me just take the LCM further. Divided by 4 so that I can cancel out by 8. So this gets cancelled out. Now I can pull this cos and put it inside, right? Put it inside. So this turns out to be 2. Why I'm doing so, you're going to realize it in a moment. So these are few things which you need to observe. I hope all of us can observe this bit. This is what? This is cos 3x. Very good. Cos 3x, which is equal to 1 by 2. Cos 3x, which is equal to 1 by 2. So now this is a simple equation which we have, which can be rewritten as higher in them. So cos 3x is equal to cos pi by 3. Right. Now what we know is we'll apply the general equation, the general solution. So we know that this is basically 2n pi plus minus pi by 3. And then we just need to split it and figure out what all values of x lie in the domain. What was the domain given? 0 to pi. So just think about the values which lie between 0 and pi. If I solve this further, so I can say, if I just put it over here, probably. So I'll say x can be, or 3x can be, it can have two values. So one is 6n plus 1 pi by 3, or 3x could be 6n minus 1 pi by 3. Just taking the LCM again. Or this can be rewritten as pi by 9, or x is 6n minus 1 pi by 9. So from here, you just need to figure out those values of n that lie between 0 and pi. What are those values? Let's quickly figure it out. So first value over here, if I place from here, if I say x is equal to, can it be -1? So -1 will give me -5 pi by 9. -5 pi by 9, it will be a negative quantity. We need to find between, so x lies between 0 and pi. That's being given to us. Is it included, not included? Included. You should be very, very careful with this. Included. We can include these values as well. So x over here could be pi by 9 if n is equal to 0. If n is equal to 1, it can be 7 pi by 9. 7 pi by 9 is also included, 7 pi by 9. And that's it. These are the only two values. The next one over here, the values of x could be, placing the value of n is equal to 0 will make it negative. N is equal to negative will also make it negative. So we'll just place in positive values. N is equal to 1, 5 pi by 9. N is equal to 2 will give me a value that is greater than pi. So these are the only three values possible. We had to find out the sum of these values. Therefore, the sum of these values would be, sum of the values would be 7 plus 5, 12, plus 1, 13 by 13 pi by 9. 13 pi by 9, Aditya. 13 pi by 9. So basically, you need to add, and this was being asked 13 pi by 9. 13 by 9 pi. So the value of k over here, we all can figure out, is 13 by 9. I hope this is fine with all of us. Right, absolutely clear. So such simple questions appear in mains wherein you just need to apply one formula, one identity, and then you're going to go ahead with the question. Let's talk about a JEE Advanced question. This was a seriously simple question of Advanced 2016. If I talk about, you can see everything once you're going to see the question over there. So what this question is talking about, it says √3 blah, blah. There is an equation given to us over here. There is an equation given to us over here. Aditya, you can check it out in the recording. And the values of x which you're going to get from here, the values of x which you're going to get from here belongs to this set. So basically, the values of x lie between minus pi to pi, where x cannot be equal to 0 and x cannot be equal to negative or positive pi by 2 because of tan and cot. Okay, so we basically need to solve and figure out the sum of all the distinct solutions again. Almost a similar question which we just did. The equation has been changed. That's it. Let's quickly do it. So if I convert everything into sine and cos, everything will be very, very simple for us. So this is √3 upon cos x. This is 1 upon sine x. This is twice of sine upon cos. So let me write it properly. Minus cos x upon sine x. Right. And then you can just take the LCM and do the manipulation. So it turns out to be √3 sine x plus cos x plus twice of sine square x minus cos square x is equal to 0. The denominator will go on the other side and that will become 0. So now over here, I hope most of us can realize this. That this is what? Cos square x minus sine square x is what? Cos 2x. Negative cos 2x, in fact. So this is negative cos 2x. We can just take that on the other side. So what are we left with? Now this is something which you should see and realize. This is 2 cos 2x. Cos 2x is cos square x minus sine square x. So cos 2x, sine square x minus cos 2x, cos square x will be negative cos 2x. That can be taken on the other side. Okay. And now I hope you can realize one more thing, that you can divide or take this 2 on the other side. So bottom line, our motto while solving the questions on trigonometric equations is to generate a trigonometric ratio which is same on the left-hand side as well as on the right-hand side. So we already have cos on the right-hand side. We'll try and generate cos on the left-hand side. So we know how we can do that by replacing √3 by 2 as sine pi by 3 and 1 by 2 as cos pi by 3. So this can be replaced as sine pi by 3 sine x plus cos pi by 3 cos x. Hopefully everyone is clear with it, right? Now in this case, this is the formula sine A sine B plus cos A cos B. That's the formula of cos A minus B. Pi by 3 minus x or x minus pi by 3. Cos of minus x is also the same, just for the ease of calculation. Cos of 2x. Now we can apply the general formula. So based on the general formula, what we can derive is, what we can say is, based on the general formula, we can say this 2x must be equal to 2n pi plus minus x minus pi by 3. We've just done almost a similar formula, right? So if I solve it further, I can basically break it into two parts. One with a positive sign, one with a negative sign. So let's go ahead and do it. So 2x is equal to 2n pi plus of x minus pi by 3. Similarly, 2x is equal to 2n pi minus x plus pi by 3. This is what you're going to have. Eventually, you can take this x on the other side, take 3 over here. So it'll be 6n minus 1 pi by 3. This is what the value of x is. Over here, if I take this x, it'll be 3x is equal to 2. So 6n plus 1 pi by 3. So if I divide this 3, so I can say, okay, I can remove this 3 and make it 9 over here. So now it's sort of simple for all of us, most likely. So we need to figure out the values of x. Now I need to check the domain. The domain was from minus pi to pi. 0, pi by 2, and pi by 2. They are being excluded, so we'll not count them. And again, we need to figure out what the sum of all the distinct solutions. So from minus pi, let me just write it so that I do not go back again and again. From minus pi to pi. Not inclusive. If you check, it's not inclusive, right? This was the question. Over here, we'll figure out the values of x from here. First of all, let's talk about the negative values. If I talk about n is equal to 0, I'll get negative pi by 3, which is one solution, negative pi by 3. If I talk about n is equal to negative 1, so it'll be minus 7 pi by 3. Minus 7 pi by 3 is less than minus pi. So we'll not talk about that value. So then we'll place n is equal to 1. 6 minus this gives me 5 pi by 3. 5 pi by 3 is also a value that is greater than pi. So we'll not consider this value as well. So this is the only value which we're going to receive over here. Similarly, if I talk about this from here, we can have what values? X is equal to minus 1, for instance. 6 minus 6 plus 1 is minus 5. Minus 5 pi by 9 is a value which is less than pi, right? 5 by 9 is a number which is a fraction less than 1. So that is included. Minus 2 will not work because that will give me minus 11, will be a higher number. 0 will work, pi by 9, 0 will work. N is equal to 1 will also work, 7 pi by 9. And n is equal to 2 will not. 13 pi by 9 will be a value which is greater than pi. So basically, these are the values of x which we wanted. And the question is asking for the sum of all the distinct solutions of this equation. So again, need to figure out the sum of all of these values. So what will be the sum? Let's figure out the sum. That turns out to be, this value can be written as negative 3 pi by 9 plus negative 5 pi by 9 plus pi by 9 plus 7 pi by 9. If you add, this turns out to be 0. Hopefully everyone is clear with whatever is there on board. Yeah. Quite simple story. So the correct answer for the question is C. Let's move on. Okay, now such questions you would have solved many a times. Over here, I've already told you one good technique in the previous class, and that technique was whenever you find odd type of terms, consider adding them or applying the formula between them. And when you have even, select them, right? So we'll first of all sort of write this as cos x plus 3 sin x, and this can be written as cos 2x plus cos 4x. This is what is being given to us primarily. Now we'll apply the formula of cos A plus cos B. So cos A plus cos B is 2 cos A plus B by 2, which is 2x, right? And sine cos A minus B by 2, which is negative x, but eventually cos of minus x is cos x itself. Plus, if I apply the formula over here, this is 2 cos 4 plus 2, 6 upon 2, which is 3x. 4 minus 2 is 2x upon 2 is x. We can take 2 cos x as common. Cos 2x plus cos 3x. Let's apply the same formula. What we're going to get? 4 cos x. And if I add these two, this will turn out to be cos of 5x by 2, cos of x by 2 is equal to 0. So basically, product of three values, this, and this, product of three values is equal to 0. This can happen when either of them is equal to 0. Either cos x is equal to 0 or cos of 5x by 2 is equal to 0 or cos of x by 2 is equal to 0. So these are basically the equations which we need to solve. Now we know cos x is equal to 0. We have a simple solution, and the solution is it will be odd multiple of pi. So x can be taken as 2n plus 1 pi by 2. In this case, x lies between 0 and 2 pi. It's very important for you to remember where x lies. 0 is included, 2 pi is not included. This is where x lies. Similarly, over here, we can say 5x by 2 can be written as 2n plus 1 pi by 2. And over here, x by 2 can be written as 2n plus 1 pi by 2. So we just need to solve them further. So from here, we can get values between 0 and 2 pi. We know those values. We do not have to basically write this out. But anyways, so one of the values is 2 pi, another value is 3 pi by 2. From here, we can get the value, we can modify it somewhat like this. It'll be pi by 5. And over here also, we can modify it as 2n plus 1 pi. So from here, we're going to get the values as n is equal to 1. We don't have to move to negative ones. No point putting n as negative because that'll give me a negative stuff. So n is equal to 0. I'll have pi by 5, pi by 5. N is equal to 1. I'll have 3 pi by 5. N is equal to, isn't it? It's 2 pi. Yeah. So n is equal to 2. It'll be 5 pi by 5, which is pi itself. So I'll write it as 5 pi by 5. pi लिख लेते हैं, कोई नहीं. Pi, and then 7 pi by 5, and then 9 pi by 5. That's it. 11 pi by 5 will be greater than 2 pi. 11 by 5 is greater than 2, right? So we'll stop over here. And now if I talk about this over here, I'll get the values of x as pi. And if I place it as 2, I'll get a higher value. So just pi. Pi and pi over here, these are the same values. We'll not count them. Recounting is not allowed. So basically, these are the only values which are getting. What we need to do, we had to count the number of real values of x that satisfy. What is the answer? 1, 2, 3, 4, 5, 6, and 7. So these are the 7 values which we require. Therefore, the answer to the question is 7. Hopefully, everyone is clear with it. Simple questions, quick to do, and normal to understand. So again, a JEE Advanced question 2015. The number of distinct solutions of this equation. So again, the question is all about finding out how many solutions are there. How to figure it out? Again, I have already stated, look, in every question, what did we do? We figured out one trigonometric ratio and equated it with a similar trigonometric ratios. And then we applied the general solution. And then eventually we figured out within that interval what all values of x will fall. Over here, if you see, you can see and realize one quick thing. If you have done enough practice, you can realize it very quickly. Powers are like 4, 4, 6, 6. So we can apply a plus b whole squared and a cube plus b cube type formula to get cos square and sine square stuff. Cos square and sine square stuff. So that will help us to reduce cos square plus sine square theta is 1. We know about it. So let's quickly see how we can solve this question. 5 by 4. Cos square 2x. I'm just keeping this as it is as of now, though you can manipulate it directly, but as of now, I'm keeping it as it is. And over here, I'm writing this as, so you can write this as cos square x cube plus sine square x cube, right? So a cube plus b cube, you can apply the formula. The formula is a plus b times a square, which will give me 4, plus b square minus ab Hopefully everyone is clear with it. Now we all know that cos square plus sine square is equal to 1. So this turns out to be 1. This actually turns out to be 1. So you're just left with this bracket. If you're going to open and write up the bracket, so basically this is being added twice. So it'll be twice of, write it, 5 by 4 cos square 2x plus twice of cos x to the power 4 sine x to the power 4 minus cos square x sine square x. Now what we can do is we can write this cos to the power 4 plus sine to the power 4 in a very simple way. And you all know about it if you have practiced ठीक-ठाक number of questions, I must say. So this can be written as a plus b whole squared minus 2ab. Minus 2ab. And 1 cos square x sine square x was already there. So now we can say this will again be 1. So this 2 will remain just a 2. So it is 5 by 4 cos square 2x plus 2 minus, this turns out to be 3 primarily. 3 cos square x sine square x. Now, as I stated in the beginning, very beginning, this is equal to 2. Sorry, not equal to 0. This is equal to 2. So this is equal to 2. Let me write it everywhere. So as I stated in the beginning, that we need to convert everything into one single trigonometric ratio, either sine or cos. So first of all, we can see that 2 and 2 gets cancelled out. It's a simple strategy which we can probably see over here. And just a moment. There is a slight error out here. This would be in a bracket. Right? So this 2 will be multiplied by this as well as by this. So this will become 4. If this becomes 4, 4 plus 1 gives me 5 over here. We will not have 3. We'll have a 5. So it's good to apply brackets to avoid such errors. Anyways, I hope this is fine with all of us. So now we can take that 5 also outside, and primarily we can write it like this. 5 and then, cos square 2x minus, in fact, cos square 2x can also be broken, right? Cos square 2x. But anyways, it's a simple thing now, most likely. Most of us will be able to understand. We can write it like this, right? Is equal to 0. Is equal to 0. So basically, what have I done, Santosh? What have I done? I've copied this as it is, and this term, I've splitted it, cos square x whole cube, sine square x whole cube. And I've applied the formula of a cube plus b cube, which is a plus b into a square plus b square minus ab. Then this was 1. I've written this as it is over here. Cos x to the power 4, sine x to the power 4 over here are being added. So it's twice of this. Then cos square x or a square plus b square. I hope you know about it. A square plus b square. This is a basic transformation which you used to do in class 10th. Can be written as a plus b whole square minus 2ab. Minus 2ab. So I've applied the same. A plus b whole square minus 2ab. Now this a plus b whole square is basically 1. So this 2 will be taken inside. This 2 will be taken inside. It will be 2 minus 2 to the 4. This is 4. 4 plus 1 gives me a 5 over here. Right? So eventually this is what am I left with? I've taken this 5 as common and taken 4 over there. So this is what we're gonna get. So it is 5 times cos square 2x minus this, I hope all of us can see, is sine square 2x. Right? 2 sine theta, 2 sine x cos x whole squared. This is how we can write it as. And this is nothing but cos 4x. So it's 5 cos 4x is equal to 0. Right? All the concepts are clear. Very good. So 5 cos 4x, this 5 can be removed because it's a basic 0. So again, we can say basically cos 4x is equal to 0. What we had to find out is number of distinct solutions where from 0 to 2 pi. From 0 to 2 pi. So x belongs to 0 to 2 pi. Therefore, you can say 4x will belong to 0 to 8 pi. So for this, cos is 0 for 2 values of x. For this, cos is 0 for 2 values of x. 2 values of x. 2 values of x. For this, it is basically, it's a periodic function, right? It's a periodic function. So for this 2 pi, you're going to have 4 periods of such sort. You're going to have 8 values. Right? 8 values. So this is the answer to the question. It's an integer type question, so you need to paste your answer, post your answer, write your answer over there. So 8 tens are the answer to the question. Okay, so sure, it's a simple stuff. What you need to do is you just need to just quickly write that bit as well so that everyone is clear. This is nothing but 2 sin x cos x whole squared, which is sin 2x whole squared. That's what we have written over here. That's what we have written over here. And these are just the manipulations to get down to such an equation. That's it. That's it. Right? And I've already told that a plus b whole squared is what and how can we write it as. So 8 is the answer to the question. 8 values within the period of 0 to 8 pi. Last question of the day goes like this, or second last question most likely. The number of points in this for which, at times what will happen, you have questions wherein you feel that you can apply some trigonometric identities or ratios to figure out the solution of the equation, but the question might be asking for something else. So this is one of such examples. So over here, if you see, it says the number of points in the entire number line for which this equation is valid, right? So basically, you need to figure out the solutions of x. Now, if at all I can graph this function, basically the question is asking for how many point of intersection of that graph is from x-axis, right? That's what the question, they will be the number of solutions. This is what the question is asking for. So let's say, okay, if I assume this to be fx minus sin x minus cos x. So now let me see the tendency of this function. The first thing which you can see very clearly over here is that if I take x to infinity, if limit of x tends to infinity, then fx is a very high value that tends to infinity. Fx tends to infinity. And similarly, if I talk about x tending to minus infinity for a very, very high negative value, you're going to, again, because it's x squared, that is the highest term which you have, again, it'll be infinity. So, for the positive infinity, for negative infinity as well as for the positive infinity, the graph is moving to infinity. So you can say that the graph is basically going like this. And it is coming, it might be a graph like this or like this or anything of that sort. So this is something which the tendency of the graph. Thereafter, in order to figure out whether the graph is increasing and decreasing in a certain interval, let's try and differentiate that. We'll figure out f dash x. Let's quickly find it out. 2x minus over here is this turns out to be x cos x. Right? I need to apply the product rule over here. Plus, minus, because there is a minus will travel inside, plus minus sin x, minus plus sin x. This and this gets cancelled out over here. You can take x common, so you'll get 2 minus cos x. Now what you know is 2 minus cos x, I have seen 2 minus cos x is always positive. Right? Cos x is always between minus 1 and 1, it will be always positive. You know about it. 2 is a higher value. Therefore, everything depends on x. So the sign of fx changes depending on x. So fx is equal, f dash x, you put it equal to 0 in order to figure out the critical point. So over here, x is equal to 0 will act as the critical point. So if x is equal to 0 is the critical point, to the right hand side, up till infinity, you're going to have f dash x to be positive, and to the left hand side is like negative numbers, f dash x will be negative, right? So in this case, what you can say is that the graph is increasing over here and decreasing over here. Therefore, what you have is decreasing and increasing graph. You can have a minima at, so minimum at x is equal to 0. So let's figure out what the value of f0 is. So over here, f0, we can very easily figure it out. f0, this is 0, this is 0, this cos 0 is 1, so it is negative 1. I hope everyone is clear. Minus f of 0 is minus 1. Therefore, what you can say is that the graph is coming from infinity and it moves down and goes up like this. There is just one bend, and exactly at 0, what happens? Exactly at 0, the result which you get is minus 1. So basically, we are getting 2 points of intersections. Therefore, what we have is 2 solutions. So this equation has 2 solutions. Quite simple. I hope most of us are clear with it. Last question of the day goes like this. In my opinion, Santosh, that's RD, or they can be other books as well. Okay, for x belonging to this, the equation this has how many solutions is what the question is talking about. And over here, again, what we can do is we can again convert it into one, trigonometric equation, one trigonometric ratio. Let's say sine, convert everything into sine and see what the outcome is. It'll be sine x plus this can be written as 4 sine x cos x, and this can be written as 3 sine x plus 4 sine cube x, 3 sine x minus 4 sine cube x. So there is a minus sign, so that'll travel inside minus 3. I hope this is fine with all of us. So this turns out to be what? Minus 2 sine x. We can take sine x as common as well. So you will get this minus 2 will be left over here. You will be left with 4 sine square x. From here, you'll be left with plus 4 cos x. From these two, you will be left with minus 2 is equal to 3 is equal to 3. Now you can convert it into cos because that's what we have over here. Converted into cos will be 4 minus 4 cos square x plus 4 cos x minus 2. 1 minus cos square x is sine square x. So this is sine x. This, if I write it, is basically 2 minus 4 cos square x plus 4 cos x is equal to 3. I hope all of us can see that. Now this, if you see, if I take negative common, will that work? Okay. So over here, I'll complete the square primarily. What I'll do, I'll complete the square. Let me still check. I've just taken sine x common, sine x common. This is what we're going to get over here. This is minus 2 cos x over here, 4 cos, 4 minus 4 cos square x, 4 minus 2 gives me a 2. And this is what we have eventually. Now we can apply. So this is 2 cos square. Let's take negative common, in fact. Negative common ले लेते हैं फिलहाल के लिए. So this is 2 cos x whole squared minus 4 cos x plus 2 plus 2. There might be, just a moment. Plus 2. Okay. Is equal to 3. Fine enough. So it is negative sine x. And this, if we just complete the square, based on it, this turns out to be 2 cos x minus 1 upon, just like we need to add a 4 and subtract a 4. So it will be 2 only. Whole squared minus 4 plus 2 minus 4 plus 2. This is what we're going to have by completing the square. So we have 2 cos x minus 2 whole square minus 2 is equal to 3, right? Completing the square, that's it. Okay, C is the answer, Wasim. Very good. So we can travel this negative sign inside. It's a simple stuff. 2 minus 2 cos x minus 2 whole squared is equal to 3 upon sine x. Okay. Okay. And what we can see now, if I talk about this term, 2 cos x minus 2 whole squared, 2 cos x minus 2 whole squared, that turns out to be, that must lie between the whole squared. So it lies between minus 4 and 4. Right, this bit, sorry, 0 to 4, because it's a square and lie between 0 to 4. 2 minus this will lie between 2 to 6. So this is a value that lies between 2 to 6. And this is a value that will always be greater than 3. Okay, so we can probably match something. Just a moment. Probably done some mistake anywhere. Oh, I hope the question is correct though. It has one solution. Okay, Aditya, what is that solution? For sine x cos x. Okay. And -2. So I've precisely have done almost everything correctly. But there might be some flaw somewhere else. Okay. So it's okay. We can take this question again in some other session. But basically, this is what you're going to be doing in order to solve the question. We can talk about this question. There is no point wasting more time on it. So we can talk about such questions in the next session. I'll pick this question as the first question in the next session. So I'll call it a day now. I'll call it a day. You can get down to a few more preparation tips on this URL. So you can get down to that part and see how the things are. Okay, guys, we'll meet in the next session. I'll talk about trigonometry. I'll start with the same question which I was doing earlier, the last question which I was doing. And in the next class, we'll primarily talk about inverse trigo as well as the other bits. Yes. Achha, chalo. There is a suggestion being already made. हाँ या चलो अगली क्लास में जाने की जरूरत नहीं पड़ेगी हमको. Okay. So we can take 2 common from here. So it'll be 2 sin x from here. Two cos square x minus 2 cos x minus 1 is equal to 0. Okay. Is equal to 3. I'm so sorry. Is equal to 3. And now we will be completing the square. Now we will be completing the square. So again, it will be almost similar. We'll talk about this question in the next class. It's a simple one. It's not that tough. We'll talk about that in the next class, in the next session. Chalo, take care, guys. See you in the next class. Bye and have fun.